In this system, we are offloading the LDPC decode, encode and heart buffer management, greatly improving throughput and reducing latency.
Here we have an example of a typical Xeon-based server fitted with a Xilinx T1 telco card. AccelerComm supports a physical BBDev driver as a software solution for the Xilinx T1 telco card for the 19.11, 20.11 and future long-term support versions of DPDK, which offers integration with FlexRAN using standard configuration achieved by referencing the Xilinx T1 card's PCI bus device function geographical address within the standard FlexRAN XML configuration. The solution requires no source code changes and only that the applications themselves are linked with the card supporting libraries. In this demo, we're making use of FlexRAN's L1 application, which implements the entire L1 pipeline along with TestMac, FlexRAN's test application, which communicates with the L1 application over the WLS interface.
On the screen here we have two applications running. On the right hand side is the TestMac application from FlexRAN, and this is interfaced by FlexRAN with an application running on the left hand side, which is the layer 1 of FlexRAN, the physical layer, and it's into here that we have our FPGA interfaced. You can see on the screen here various different bits of run-up. At the top here, FlexRAN is calling into our FPGA to initialize it, and there's various different parts here initializing the queues. If we look down at the bottom of the screen, we can see the initialization of our FPGA. So we have AccelerComm's FPGA. We have 6 decoders having a parallelism of 16 LLRs per clock cycle, running at 218 megahertz. This is the input interface clock speed. The actual SDFEC itself, the LDPC decoder, runs at 666 megahertz, but this is the interface. We also have 2 encoders, a parallelism of 64 running at 218 megahertz for the interface. Again, the LDPC encoder itself runs at 666 megahertz. If I switch over to layer 2, we can run a particular test. Okay, so we've just run a test. This is a 100 megahertz test using numerology 1. And we can see layer 2 running through. And over on layer 1, if I scroll down, we can see the result of this. Okay, so it's run through and we can see various different configuration that's been used for this test over on the layer 1. And back on layer 2, we can see that the test has passed.